Today we will be discussing Archimedes' principle and how different types of ice, such as freshwater ice and sea ice, have different effects on sea levels. Archimedes' principle is the idea that when you place an object into a liquid, if the liquid that it displaces is the same weight of the material, then it will float. If it is not, then it will sink. However, if it does float, the force that keeps the item afloat is called the buoyant force. Here we can see that the weight of the water that the ball displaces is less than the ball and therefore it sinks. However, when the hull is placed in the water, the amount of water it displaces has the same weight of the hull and therefore it is kept afloat. So we can use the equation mass equals density times volume in order to work out the mass of an object being submerged into a liquid or the volume of it. Take this for example. We have a jug with 0.002 meters cubed of water inside of it and with a density of 1000 kg per meters cubed. Therefore, we times these together in order to get the mass, which equals 2 kgs. When we look at icebergs, however, we have to try and work out the volume because we know the mass and density. We can just rearrange this formula to give us volume equals mass over density. Here is an example. Now, submarines use Archimedes' principle in order to surface and dive underwater. So, when a submarine wants to surface from underneath the water, it fills tanks with air. Because air has a less density than water, the overall density of the submarine becomes less than the seawater surrounding it, and it uses the buoyant force to rise. And the reverse happens when it wants to sink. The submarine releases air from the tanks, and this increases the density of the submarine. And the water it displaces weighs less than the submarine itself, and therefore it sinks, as there is not enough buoyant force to keep it up. According to Archimedes' principle, ice caps that slide into the water will displace the same amount of water it will melt into, and therefore sea levels will not rise. However, we must remember the differences in density of these types of water. Seawater has a higher density than freshwater. This is why the ice caps float in the sea. So therefore, because the seawater has a higher density than the freshwater ice caps, when the freshwater ice caps melt, they contribute a greater volume of meltwater than they originally displaced. This can be proven by looking back at our mass equation. So here we can see the equation mass equals density times volume. And to rearrange it to give us volume, we get volume equals mass over density. With this equation, we can find out how much volume an object, in our case an ice cube, providing we have the mass and density. So let's first look at a seawater ice cap with a mass of 1 million kgs and a density of 1029 kgs per meters cubed. So we put this into our equation and we get a volume produced of 971.8 meters cubed of water because the seawater and the ice cube have the same density. The amount of water that this ice cube displaces is equal to the amount of water it will melt into, and therefore will not change the sea level. However, when we look at a freshwater ice cube, we can see that we have a mass of 1 million kgs and density of 1000 kgs per meters cubed. When we put this into our equation, we get a volume produced of 1000 meters cubed of water. And because the densities of the seawater and the freshwater is different, it produces more volume for the amount of water that it displaces, and therefore this is when sea levels rise. So when we look at the world, the North and South Pole have different ice at it. And therefore, if they were both to melt, they would have different impacts in the world as we know it today. Let's look at the South Pole. The South Pole is made up mostly of sea ice, seawater that is frozen to make ice. And therefore, as explained in the previous slide, because the densities are the same, when it melts there is no sea level rise. The North Pole, however, is a different story and has large amounts of freshwater ice locked up in glaciers and ice caps. If these melted, it would cause sea levels to rise because the ice is made from freshwater, which has a lower density than seawater. Just because water in an ice cap or glacier is not moving and is locked up does not mean that it does not have a direct effect on other aspects of the water cycle and weather. For example, ice is very white, and since white reflects sunlight and thus heat, large ice fields can determine weather patterns. Air temperatures can be higher a mile above ice caps than at the surface, and wind patterns, which affect the weather systems, can be dramatic around ice-covered landscapes. Also, besides offering a habitat for many creatures, they also reflect heat from the sun. Here we can see a diagram of solar radiation and infrared radiation, as well as other radiation being reflected by the glacier because it is white. Ice caps and glaciers do have a large role in the environment. So, say we manage to burn all of our natural resources and add 5 trillion more tons of carbon into our atmosphere, we would see an average temperature of 80 degrees Fahrenheit, and it would melt all 5,773,000 cubic miles of water locked up in glaciers and ice caps, this being fresh water. This water would change the sea level as all of the water locked up in these natural forms have a smaller density than the seawater, and therefore when the ice melts it would produce more volume than the amount it displaces in the sea as it expands, and therefore sea levels rise. Here we can see our homes as we know it in London would be destroyed, most of Amsterdam would be underwater, Helsinki, Stockholm, these large cities would all be destroyed. Therefore this could be very destructive to the world we know it today, and only an ice age would be able to refreeze the ice melted. So, in short, freshwater ice cap melting is an issue that must be controlled by the world, otherwise we could see many high populated cities submerged in the not so distant future. Cheers for listening.